Hello, everyone. You ever wondered how the Earth we live on was formed? Billions of years ago, this place was just a giant dust cloud in the vast universe. Today, we will travel back in time, discover the story of the birth of the solar system and the Earth, a dramatic and magical journey. Like, subscribe, and let's get started. 4.6 billion years ago, the journey begins. Nebula, the cradle of the solar system. It all started with a solar nebula, a giant cloud of dust and gas, mostly hydrogen and helium, left over from ancient stellar explosions. This cloud was millions of kilometers wide, floating in the cold of space. But then, a sudden event changed everything, possibly the shock wave from a nearby supernova. The cloud began to contract, spinning faster, like an ice skater pulling her arms in to spin faster. Over hundreds of thousands of years, the nebula continued to shrink, eventually forming a glowing ball of hot gas. At its center, a baby sun was born. Meanwhile, most of the nebula had become an orbiting disk of dust and gas called a protoplanetary disk. This process took millions of years, creating a protoplanet, the precursor to the sun. But how exactly does a lifeless cloud of gas turn into a bustling planet full of life? How do we get from here to here? Let's take a closer look. As the sun ignited, the remaining dust and gas in the protoplanetary disk began to clump together. Tiny dust particles collided, sticking together and growing larger and larger. These clumps of rock were called asteroids. For millions of years, asteroids continued to form and collide with each other. Gradually, these collisions caused the asteroids to merge, forming larger bodies. Over time, these protoplanets grew larger and larger, eventually forming the planets we know today, including our Earth. The process of dust particles sticking together to form larger bodies is called accretion. All the planets formed in a similar way, but their composition varies greatly. Rocky planets such as Mercury, Venus, Earth, and Mars are mainly composed of rock and metal. They formed closer to the Sun, where temperatures were high enough to burn off lighter elements such as hydrogen and helium. Gas giants like Jupiter, Saturn, Neptune, and Uranus formed farther away from the Sun, where it was cold enough for these light elements to remain frozen. The further away from the Sun, the more volatile compounds could exist, leading to the formation of gas giants. You might think that the formation of the solar system would have been a peaceful process, but in reality, it was quite the opposite. Early Earth was constantly being bombarded by asteroids and meteorites. Some were small, others were huge. Many of these impacts melted parts of Earth's surface, causing a thick, hot, liquid layer called magma to flow over the planet. Although it may sound scary, this constant bombardment was actually crucial for shaping Earth. It helped our planet to heat up and melt, allowing heavier elements like iron and nickel to sink to the core, while lighter elements like oxygen and silicon rose to the surface, forming the crust. In addition to bombarding Earth with debris, these impacts also brought water to our planet. Scientists believe that many of the asteroids and meteorites that hit Earth carried water from other parts of the solar system. This water, along with gases released from volcanic eruptions, eventually formed Earth's first ocean. Now let us focus on one particular impact that played a crucial role in the formation of the Earth and the Moon, about 4.5 billion years ago. When Earth was still very young, it was hit by a Mars-sized body called Theia. This collision was so violent that it ejected billions of tons of material from both planets into space. Over time, this debris formed a new body, our Moon. This is known as the Giant Impact Hypothesis, proposed by William Hartnett and his colleagues in 1975. According to this hypothesis, matter from Earth and Theia merged in orbit around our planet, eventually forming the Moon. This theory is supported by computer simulations that show that a collision between Earth and Theia could explain the Moon's current size and orbit. You probably know that the Moon is Earth's natural satellite that revolves around our planet and affects tides and stabilizes Earth's tilt axis. But did you know that the Moon also protects us from dangerous space debris? The Moon's gravity pulls Earth's atmosphere to its surface, creating a protective shield against meteors. And even in the past, the Moon may have protected Earth from asteroids. For example, a series of meteorites known as the KPG or Cretaceous-Speleogene event occurred about 66 million years ago, causing mass extinction, including the extinction of dinosaurs. But according to some scientists, the moon may have saved some species by pulling aside many asteroids that otherwise would have hit Earth. So you can see that the moon has always played an important role in the history of the Earth. Its formation was a key moment in the development of life on our planet. But now let's go back to the past and continue our story. After the collision with Theia, Earth was completely changed. The impact had heated and melted part of the metallic core, separating it from the silicate mantle and forming a solid inner core and a liquid outer core. This process, along with Earth's rotation, created a magnetic field that protected our planet from the solar wind, a stream of charged particles from the sun. This magnetic field made it possible for Earth to retain its atmosphere and water, which were vital for the emergence of life. Also, during the formation of the solar system, many small bodies like asteroids and meteoroids remained between the orbits of Mars and Jupiter. Over time, some of them fell to Earth, bringing organic molecules, the building blocks of life, to our planet. While Earth was still very hot, these molecules likely decomposed. But as Earth cooled down, they began to accumulate in the oceans. Eventually, these molecules combined to form the first amino acids, the building blocks of proteins, and then more complex organic compounds necessary for life. And there you have it. A giant cloud of dust and gas, the Earth and the solar system were born over millions of turbulent years. This was just the beginning of a long journey leading to the life we see today. Did you like this story? Then stay tuned for the continuation of our adventures in space. In the next episode, we will talk about how Earth continues to change and become our home. What will happen to our planet? Will there be new life forms? Leave your comments and suggestions below. And of course, don't forget to like and share this video. Till next time, explore the vastness of space and keep asking questions. Who knows? You may be the one to discover the secrets of the universe. All living things on Earth depend on the unique conditions that make our planet habitable. Water, atmosphere, stable climate, and magnetic field are just a few factors that make Earth special. When you think about it, it's incredible that our planet has all these things. Our solar system formed out of a giant cloud of dust and gas. The Earth formed out of dust and gas and water from space. We keep getting bombarded by comets and asteroids. Life on Earth seems like a miracle. However, we tend to take it for granted. We hope this video reminded you of how amazing Earth is. If you liked it, give it a thumbs up. Also, if you enjoyed watching it, share the video with your friends and family. Subscribe to our channel to watch more interesting videos. Thanks for watching, and see you next time.